Hi everyone, welcome to Vedantu English. I'm Diksha Ma'am, your chemistry master teacher. So everybody do let me know in the chat box if I am clearly visible and audible to all of you or not. Right? So it's been a long time that I have taken your class because I was not well. But today I'm very excited for the class. But do let me know if my voice is audible to you because I will not be shouting like loudly because doctor has advised me to control my emotions while teaching, right? And be as normal tone as possible, right? So that's the reason I'll be talking little bit in a lower volume. Huh. But you let me know if I'm like if that works for you or not. Right? Okay. So hi Abhijit, hi Sanjay, Rama Raju, Vrat, Janet, how are you all? So yes, I'm also so happy to see you guys here, right? So firstly, tell me, do you remember anything of structure of atom? Have you revised anything? Like, have you completed the backlogs that you had? Because 10 days you had, right? So I assume that you must have done little bit of like, all the backlogs that you already had or any practice, right? That was needed from you, right? Okay. Welcome, beta, welcome. So, yes, everybody, do let me know so that we can start with the session without wasting any further time, right? And before going through that, I just want to inform you about the MVSAT program, right? So, you can see this here. This is our MVSAT program. So, this is totally yes. So this is completely free of cost, right? You can register yourself here, right? Basically, this is your Mega Vedantu Scholarship admission test, right? So here, nationally, you will be competing with the other students, and according to that, you will have this scholarship, right? It is completely free of cost to register yourself into that. Preferable is if you can go to nearby offline center and then give your test. But otherwise, if nearby offline center is very far away from your home, then what you can do is approach to the nearest online center, right? That means nearest offline center, approach to them and take your online test. But preferable will always be offline center, right? Okay, so 100% scholarship you can get, right? And win prizes worth 2 crores, right? Including laptops, phones, and drones, right? Free course learning, all these things you will get here, right? And all the courses will be 100% free of cost for you, right? So, how do you enroll yourself? Over here, you have MVSAT register now. Click on here and you will get to this particular page. Fill in your details here, and after filling the detail, preferred city, everything, right? And that's it. You are registered. That's it. That's it. What you have to do, right? Okay. Understood, everybody? Yes. Yes, I definitely remember you, beta. My throat was not well. It's not like I have memory loss, right? I definitely remember you, Abhijit, Ramaraju. I definitely remember my students, okay? So, yes, everybody, and where is the energy? After so many days, I'm taking the class. Ma'am, is the MVSAT tough? Now, that depends on person to person, right? That depends, right? But otherwise, it will be of the level which will help you. It's not like we will ask you JEE advanced level of questions, right? That will not be there. The questions that we need to test your efficiency, that will be there in the scholarship test, right? Not JEE advanced level of questions, okay? Definitely not, right? Okay, yes. So now let us start with the session. So if you see that the topic is Schrodinger wave equation, quantum numbers, nodes, and what is the electronic configuration, all these things we are going to do today, right? So all these things are interconnected to each other, right? And this is actually, some students feel that this is a very complicated topic, but if you actually learn it in a better way, because I have given you also here, I have taken screenshots of some 3D models to make you visualize the orbitals, everything, right? So even the graphs I will teach you with a very simple rules, right? So you don't have to worry about anything, right? All you have to do is just focus on the lecture and have one notebook and pen, and I'm not asking you to write down everything, but when I ask you some questions, you should be able to answer it. Okay? Right? Okay, students? Yes. So let us. Ma'am, how are your health is okay? Health is like not that completely recovered. It's still not fine, but I'm just trying to, take lectures if I can. Right? Okay? Yes. Whew. So now starting with the first thing, that is Schrodinger wave equation. Now last model was Bohr model of an atom, right? We were discussing about dual nature, right? We discussed about Heisenberg uncertainty principle. Now Heisenberg told that, what was Heisenberg uncertainty principle? He told that Bohr was saying you can measure the radius, you can measure the velocity of an element. But Heisenberg was like, no, you can't do that, because simultaneously velocity and position you can't measure, right? Because of Heisenberg uncertainty principle, Bohr model was ruled out, right? So now there is this new theory, that is quantum mechanical model of an atom, that is based on that every atom follows probability. The electrons in the atom, they are on basis of probability. Like if a box is closed, right? You have put a cat inside the box and now the box is closed. You visit your relatives and you come back home later after 10 hours, right? 50% chances are there the cat will be inside the box, but 50% chances are the cat might not be inside the box, right? So that is Schrodinger's, I am not making up this story, this is actually Schrodinger's cat experiment, right? So that's how he made everyone understood that if you can't see anything, there is probability of finding that thing, right? So same way he gave a probability of finding the electron. Altogether, this is a very vast topic. Right now, talking about everything that is going on in physics related to space, right? Most of the things are going on based on the quantum theories, right? Higgs field, everything is the result of quantum theory. So it's a very vast topic. It's like a big ocean. You are just learning a drop of it. That's it, just a drop of it. So there'll be so many questions in your mind. You can just ask me over there in the chat box. I can see your answers in the chat box as well. But before that, let's understand one by one. Okay, it's like here's so many dots that I'll tell you. After that, we will connect all these dots. Okay, now first is Schrodinger wave equation. So this equation looks like this, right? So in bachelor's and master's, right, especially in physics, right, we solve all these kind of equations. Not even solve, we solve derivations, right, which is also a very small version of those big lengthy calculations that Schrodinger has already done, right? Ma'am, is solving this equation in your syllabus? No, right? Nothing is in your syllabus regarding this equation. You just have to remember that this is the equation, right? Where this is called psi. This is called psi, right? It is represented as this one U and one line over there, that is called psi. Okay. Now this psi is called the wave function, right? He's saying that electron is dual nature. It is also existing in wave function, right? So that psi is representing the wave function. Just have patience, okay? I'll tell you everything about it. This is called the wave function. We know that there are three coordinates. One is x-axis, then there is y-axis, then there is z-axis. So along x-axis, along y-axis, along z-axis, how it is differentiated, right? That is represented by this x-axis, this y-axis, this z-axis term, right? And this is a constant 8 pi square m by h square. H is the Planck's constant, m is the mass, pi is pi only 3.14. E is the energy, V is the potential, and psi is the wave function. He said that this equation is always applicable for a wave function. Always a wave function is going to follow this particular equation, right? That is beyond our scope, so we are not going to get into it. You just need to know that this is the equation, that's it, right? So the fundamental equation of quantum mechanics is developed by Schrodinger, that is represented by this. A simplified version of this particular equation is H psi equals to E psi. Now, right now, just focus on understanding the terms here. Okay. What is this psi? This is nothing but this is wave function. Okay. What is this H? This is called Hamiltonian operator, right? What is this E? This is called energy. Now I'll tell you, right? I know you're getting confused here. Let's take an example here. See, if I say, okay, now I'll tell you in mathematical form because you guys are JEE students. So I think by this example, this will get into your head what exactly I am telling you, right? Tell me one thing. Function are different type of functions we have. Like psi is the wave function, right? Similarly, we have a differential function, right? These are the functions. Sorry, these are the operators, right? Function can be any value. Like for example, I have an operator. That is, let's say, d by dx. Different operations we have, right? Operation is whenever we are going to an hospital, whenever we are going to a hospital, right? If there is problem in your eyes, you will have eye operation, eye surgery. If you have problem in your lungs, you will have lung operation. If you have problem in your throat, like me, then you will have, like, throat operation, right? So whatever is the problem, according to that, you will have different operations. Similarly, you have different operators in mathematics. There is plus, addition is an operator, subtraction is an operator, differentiation is an operator, integration is an operator. All these are operators, right? Out of them, I am giving you one example, that is differential operator. Okay. Now, I'm assuming two things here. Okay. I'll just copy paste this slide here. Here I am assuming that wave function is, or you can just say function is x raised to power 4. Now, can you see always here also you have operator is working on the function. That means operation will be on the patient. So it's like this is the operation, this is like the operation, and this is the patient. This is the patient. Okay. So always this happen, operation we will do to the patient, or we will do operation to the person who is with the patient. For the patient only we will do like operation, right? So here also we are doing the operation. So this is d by dx. This is x raised to power 4. Now this is a very simple example that I have given. We know that this x cube, this will be the answer here, right? Now can you see this was the wave function. We can't see on the product side, we can't see anywhere x raised to power 4. That means the person is dead, right? that means the person is dead. That means the wave function that we have sent to the operator, this was the operator, this is the wave function. When operator works on the wave function, you are not getting back your wave function. That means this is a non-eigen function. This is a non-eigen function. Then ma'am, what is this eigenfunction? Let's see that. If I say function is e raised to power 2x, okay? Now if you have dy by dx, e raised to power 2x, differentiation will be, this will be 2 into e raised to power 2x, okay? That I think for JEE aspirants, I don't even need to tell you this, you are pro in this. You're better than me in this, right? So, now tell me one thing. This was my function. I have sent the patient to the operation theatre and the person is as it is. That means the person is coming back alive, right? If the person is coming back alive, the wave function is not getting destroyed. The wave function is as it is in the product side also. I'll say this is a eigenfunction. This is a eigenfunction. And first you better tell me, are you clear with this concept? What is operator, right? So just like I told you differential operator, similarly, there is an operator that is called Hamiltonian operator, right? Similarly, there is an operator H that is called Hamiltonian operator, okay? And this is the function. When this operator is applied to the function, your wave function is as it is. Now tell me, is this wave function eigen? Yes. Because whenever Hamiltonian operator is applied on the wave function is getting as it is, and the value that is coming apart from this wave function, that is your energy, that is your eigenvalue. Okay, so we can say that this is an eigenfunction, eigen wave function. Okay, everybody, that's why we are saying psi is wave function in which all dynamical information about the system is contained, right? Tell me guys if that is clear or not. Thank you so much. Thank you so much, Lone Rider. Thank you. Okay. Yes. Now, better tell me if that is clear or not. I have told you about eigenfunction. है ना? Ramaraju, we will have a different discussion on that. Okay. Firstly, please focus here. Okay. Firstly, please focus on the class. We will have a separate discussion. Tell me if that is clear or not. Yes, guys. If that is clear or not, this is what we have discussed till now. This is the Schrodinger wave equation. This is a short form. This is Hamiltonian operator, wave function, energy, and wave function is getting as it is even after application of operator. That means it's an eigen function, right? We know that E is nothing that gives information about possible energy levels of the electron. Now, this is first equation. This is a simple form of Schrodinger wave equation, right? But our task is not to solve this equation. That is not our task. Our task is to understand what is the application part, what it is going to give you. Okay? So, energy here, it is going to give you the information about possible energy levels of the electron, where the electron is lying, and this psi is going to give you wave function of the electron associated with each energy level. each energy level, firstly, so you will have different energy levels. Then for each energy level, you will have a wave function associated with it. This is what we call, on solving this equation, we will get these things. Okay. Now, in a simpler version, I can also just simplify this thing for you, that whenever you solve Schrodinger wave equation, right, you will get two values. Okay. One will be real value, other will be imaginary value. Iota type of value, right? So that you have already studied in maths, right? This we are not going to discuss. We are going to see that the solution of this real value will be in two forms. One will be the graphs, where we are going to discuss nodes, antinodes, right? And here we are going to discuss quantum numbers. Quantum numbers. These are the two main things that we are going to discuss. And you know what? One very important question that they ask you from this equation, that is, by solving this equation, how it is solved, this is not in your syllabus, right? What is in your syllabus? That after solving this, you get quantum numbers. You have 4 quantum numbers, but this equation is only going to give you 3 quantum numbers. Fourth quantum number is not a solution of Schrodinger wave equation. Only 3. First is principal quantum number, then you have azimuthal quantum number and magnetic quantum number. So these 3 are the solution of Schrodinger wave equation. You can also write it here. Spin quantum number is not a solution. The fourth quantum number, that's a very important question. Fourth quantum number is not a solution of Schrodinger wave equation. Okay, yes everybody. Paki, you will have to study here only, right? Okay, yes. Everybody tell me if that is clear or not. Ma'am, give any example for the Schrodinger equation. Rama Raju, I'll definitely give you an example of Schrodinger equation, but for that you have to be in BSc second year. Because I have studied this in BSc second year. So you have to be in BSc second year, and that too you have to take BSc in physics also and chemistry also. Then only you will get to know about it, right? So that is not it. That's what I am telling you. That this is what you have to learn is, this is the equation. You don't have to solve this equation. Nobody is asking you to solve. You just have to know what are the parameters, what are the different, what is this, what is this, what is this, what do you mean by this equation? Then you have to understand this eigen equation. Then you should understand that what is the solution. Solution is, it is going to give you quantum numbers and graph. This is our main topic, right? Okay, yes. Not for JEE also. Okay, understood? Quantum numbers and graphs. So I'll start with the first thing. First is, let's get into quantum numbers. Okay? To understand quantum numbers, you should understand, like, okay, so where you live in your room, right? You have a specific room where you actually study, right? So similarly, electron also has its own room. Okay, electron is also living in its room, right? Now your task is to find out in which room electron is living. That room is called orbital, right? So what is an orbital? A space in an atom where the probability of finding the electron is highest. Where I can say the probability of finding the electron is highest, that is called an orbital. And orbital have different shapes. That also we will learn about. But before that, you should understand that psi, who will tell us how you will get to know that, like, if I say this is the platform, okay, if I say this is the platform, okay, the probability of finding the electron is highest here or here or here or here. Who will tell you that? I'm saying if the probability of finding the electron is highest in this particular sphere, let's say I am saying the probability of finding the electron is highest in this area. You will say, ma'am, who told us that the probability of finding the electron is highest here? I say the probability of finding the electron is highest in this area and in this area. Tell us, ma'am, who told you this? So who told us this? Our solution, right? That means when you find out the value of psi wave function, it does not have its own it does not have its own value, but you can say it does not have any value. That means this psi value is not going to tell you anything, right? But psi square, this will tell you the probability of finding electron. So there is an equation that is given by Schrodinger. He said that you solve this equation, you solve the value of psi. How it is solved, it is not in your syllabus, right? When you solve the value of psi, you take the square of psi, and what you will get is probability of finding electron, right? And where you will see probability of finding the electron is maximum, that is going to be your orbital. Okay? Tell me if that is clear. But it is taking a lot of efforts to even speak. Okay? If you're going to do this now, I'll ask the team to cancel my classes here, because I already have classes in batches also. Okay? So if you're not interested, if you're like, ma'am, I don't want to be serious, then why would I have like literally 25 antibiotics in a day? Almost I was in an operation theater. Okay? I don't want to get into that phase again. I am here just for you guys. If you're genuinely not interested in responding, in answering, then I will take maybe one class in 2 weeks, and that to 1 hour. Okay? Then you can see for yourself what you want to do, right? But if I am here, then I need your efforts as well, because my throat is not working. Okay? Now, let's see this. Now, let's find out quantum numbers. So, there are 4 quantum numbers that we have. One is principal quantum number, right? One is principal quantum number. Then there is azimuthal. Then there is magnetic. Then you will have spin. Now, these 3, this one, and this one, principal quantum number, azimuthal quantum number, and magnetic quantum number. These are the solutions of Schrodinger wave equation. But this is not a solution of Schrodinger wave equation. Okay? This is not a solution of Schrodinger wave equation. Now, if you see this here, it's like you are finding the address of your friend. Okay, so you want to find out the colony of your friend, in which society he lives, in which house he lives, in which room he lives. Okay, that's only your friend is living in the same city. Okay, now if your friend is living in the same city, then how you will find your friend? You will call them, you will be, hi, which society you are living in. They will tell you, this is my society. So here the societies, I'm just comparing this with your life. This is the society. Okay. Then from society, in one society, you will have so many houses. You will say, what is your house number? Right? So you will ask them the house number. Right? After asking house number, you will say, yes, I have reached your house, but in which room you are living? In which room you are living? And then you will see whether that person is living in a good manner or a bad manner. Good manner means plus half or minus half. Is the room of your friend fully like well maintained? There is no chaos in the room, or your friend is living like, oh my god, clothes are on the AC and clothes are like shoes are there and here, right? So is your friend living in a very messy way or in a good way? Okay, now similarly, like you go from society to house to room, then to the way they are living. Similarly, we'll go from spin quantum number to azimuthal to magnetic quantum number, right? So if you talk about the spin quantum number, right? Uh, I'll actually talk about that one by one. Okay, I'll talk about that one by one. First, you need to see each of them, right? Spin quantum number. It's like a society. Okay, it's like a society that you are living in. So, in your society, tell me one thing, right? Your society can have one number, two number, three number, four number. Right? What's your street number? Street number 1, 2, 3, 4, 5, 6, like that is your society, right? So, society, we know that what exactly happens here. Society is actually shell. It is telling you the shell number, which is represented by this n. N cannot be equals to 0. It can be equals to 1, then 2, then 3, then 4, and so on up to infinity. And as the value of n increases, the energy will increase. As the value of n increases, principal quantum number is nothing but it was called as orbit in Bohr angular momentum. In Bohr model, this principal quantum number was called as orbit. Understand? In we used to call n is equals to 1, n is equals to 2, but there we used to call it orbit number. Right? Now we are going beyond it. We are looking what is there in this orbit. And now in quantum theory, it is called as shell. Okay, it is called as shell. So shell can be equals to 1, 2, 3, or 4 up to infinity. As the value of n increases, energy will increase. Okay, and as the value of n increases, size will increase. Okay, as the value of n increases, size is going to increase. That means if you say n is equals to 1 has smaller size than n is equals to 4. I'll tell you why. What is the reason? Right? Because if you see, wait a minute. Uh, okay. Yes. So if you see this here, This also will discuss that why as n increases, size increases. Right? Now, if you see, it is always in a positive integer up to 1, 2, 3, up to infinity, determines the size and to large extent the energy of the orbital. That's why we are talking about energy and size here. Right? Maximum number of, this is the formula. So, maximum number of orbitals, don't look for maximum number of electrons. That will come to that again. Just now, for now, just remember number of orbitals in a shell is n square. Right? If I say, so this is the formula, we can come back to this one later, right? Now just remember, if you talk about azimuthal quantum number, azimuthal quantum number is actually telling you the subshell. In one shell, how many subshells you will have? In one shell, you will have 0 to n minus 1 subshell. Okay? If I say n is equals to, if I say n is equals to 1, then L will be equals to 0 to 1 minus 1, that is 0. If I say n is equals to 2, so L will be equals to 0 to 1. That means 0 and 1. If I say n is equals to 3, so L will be equals to 0 to 3 minus 1, that is 2. That means 0, 1 and 2. Right? Similarly, if I have n is equals to 4, then it will be equals to 0 to n minus 1. N is 4, so L will be 3. So 0 to 3 means nothing but 0, 1, 2, 3. Can you see that over here? Can you see that over here? So L value is dependent on the value of the shell, right? So that means here, if you see one thing here, this 0, 1, 2, 3 has a specific name. Like each house has a name, na? Some are saying my house is called White House. Someone is saying very rich. I have seen some people like really rich people. Outside their house, it is written as Kutia. Like it will take me 3-4 lives to buy this house. And you are saying Kutia? I'm like, why? Like some people, right, they will name their house as White House, right, Grey House, Pink House, right, Yellow House, right? So different names people give, right? Like Shah Rukh Khan has given his name to his house as Mannat, right? So different houses, names we give. Similarly, to your friend's house who is living in this society, right? You have given each house, each number, each house number has a specific name. If house number is 0, it will be S. If it is 1, it is P, D, and then F. Okay, understood? This is very important. Now, if you see this here, for n is equals to 1, you have only one subshell. For n is equals to 2, here you have only one subshell. One subshell. Here you have two subshell. Here you have 1 to 3 subshell. Here you have 4 subshell. So can I say number of subshell, inner shell is equals to n. Unique part is if you are going in a society, right? That is the name of number of the society is society number 3. That society is going to have only 3 houses. If the number of the society is 1, that society is only going to have 1 house. If the society is 10, n is equals to 10, it is going to have 10 houses, right? So the number of the shell, the number that you have shell, will define the number of the subshells in that shell, right? Okay, tell me if that is clear. This is a very important point. Okay, understood, guys? The number will represent the number, principal quantum number will tell you the number of subshells in a shell. Okay, right, everybody? Now, let's find out. This we will talk about. Formulas I'm going to come, don't worry. Now, let's talk about magnetic orbital number. Now, I'm saying I am outside your house. In which room you are staying? Okay. So, room will be Mn, that is represented by minus L2 plus L. Okay. If I see this here, if I say I am living in L is equals to 0, I am living in L is equals to 1, I am living in L is equals to 2, I am living in L is equals to 3. Now, who will tell me that what is the name? L is equals to 0 house is called what? Sharma, Kutia, White House, Mannat House. What is the name of L is equals to 0? It's called S. This is called P. This is called D. This is called F. Okay. Now, if you see this here ML will be equals to 0 because minus 0 to plus 0 is 0 only. Here it will be equals to minus 1, 0 plus 1 because it is minus 1 to 0 plus 1. Here it will be equals to 2, so it is minus 2 to plus 2, so it is minus 1, 0 plus 1 plus 2. This is equals to 3, so it will be minus 3, minus 2, minus 1, 0, and this is 1, this is 2, this is 3, right? Now, can you see one very simple thing here, that in S, right, you have only, this will define the orbitals, okay? Like principal quantum number was telling you shell, right? Then we went towards subshells, then we went towards orbitals, right? So this is telling you the orbital, okay? This is telling you the orbitals. This is the thing that we were trying to find out. Orbital is the room of the electron, where it is staying, where our friend is staying, right? So here in S subshell, you have only one orbital. In P subshell, you have three orbitals, 1, 2, 3. In D subshell, you have 5 orbitals, 1, 2, 3, 4, 1, 2, 3, 4, 5. In F subshell, you have 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay. Now you know that why, while writing the electronic configurations, we have for S we draw 1 box, for P we draw 3 boxes, for D we draw 5 boxes, this we draw 7 boxes, right? Because of the orbital, right? Now I am coming back again here, right? If you see this here, society was nothing but it was telling you the shell. Okay, this is nothing but this is telling you the subshell. Shell can be 1 to infinity, subshell can be S, P, D, F, G, H, like that. Room is nothing but this is orbital. This is telling you the orbital, and this is telling you the spin. Now, this is the whole sequence. If you see this here, from shell to subshell to orbital. Now, in each orbital, now in each room, who will stay? So, there is a rule that in one room only 2 people can stay. And those 2 people will be opposite, right? That means here only 2 people will stay. Here only 2 people will stay, right? 2 means people means electrons. So in one orbital, you will always have 2 electrons. Okay. So here you have this much. So here you have one orbital, 2 electrons. Here you have 3 orbital, 6 electrons. Here you have 5 orbitals, and you have 10 electrons, and here you have 7 orbital, and you have 14 electrons. Okay, Tell me, guys, if that is clear to everybody or not. Okay. Yes, everybody, tell me if that is clear to everybody or not, because now we are moving towards the formulas, right? Now, if you see the formulas, right, the formulas will be simple formulas we have. Instead of telling here, the detailed formulas are written here. What I would love to do is to show you this particular chart, which will give you a simple conclusion of all the formulas. Okay, everything important is written on this particular chart, right? Four quantum numbers you have: principal quantum number, azimuthal quantum number, magnetic quantum number, spin quantum number. Shell, subshell, orbital, and spin. This will tell you the energy, the size. Okay, this will tell you the energy or the size of that particular orbital, of that particular shell. This will tell you the subshell, that will tell you the shape. Okay, this is going to tell you the shape, because subshell can be S, P, D, F. S has a different shape, P has a different shape, D has a different shape, F has a different shape. So each subshell is going to tell you the shape, right? That if you see the house, right, every house will have its own architecture, right? So similarly, this house is going to tell you the shape. Orbitals, that room where your friend is staying, that is going to tell you the orientation. Orientation means, if you see, we have px, we have py, we have pz, we have dxy, we have dyz. So this xyz is nothing but it is the orientation along x-axis, along y-axis. What is the orientation? Okay, so that is going to tell you the orientation, right? Then last one is spin quantum number, that will tell you the rotation, whether it's clockwise or it's anti-clockwise, how it is rotating, right? All the formulas written here. This is from 1 to infinity, 0 to n minus 1, minus L2 plus L plus half or minus, right? Another formulas are written here because I want you guys to also remember this. So that's why I have made this table for you, right? So simple way of remembering this is number of subshells in a shell is n, but number of orbitals in a shell is n square. Okay, number of orbitals is n square. Number of electrons, because in one orbital you have 2 electrons, so it will be 2n square. Okay. Now, here we talked about a shell. In a shell, beta, these formulas are very important, right? Please focus here. Number of subshell in a shell is n. Number of orbitals in a shell is n square. Number of electrons in a shell is 2n square. Now let's talk about a subshell. They have given you, it is S, it is P, it is D. Then you will say number of orbitals in a subshell is 2l plus 1. You can also put this here. Okay. Okay, how many orbitals it should have? L is 1, so it should be 2l plus 1. That is 2 plus 1, that is 3. Isn't it? Yes, it is coming out to be 3 only. If L is 2, so it will be hello. Guys, so sorry. I think because of some technical glitch, it went off, but I am back. Okay. Everybody, now tell me if I am visible and audible to all of you or not. Yes, everyone. So this is our video. This is about the all the formulas related to that, right? If you talk about number of subshells in a shell, this whole is in a shell. This thing I am talking about, inner shell. Inner shell. This if they have given you in a subshell. Number of orbitals in a subshell is 2l plus 1. Maximum electron will be 2 into 2l plus 1, that is nothing but 4l plus 2. Okay. Angular orbital momentum is under root l plus 1 h by 2 pi. And angular spin momentum is under root s plus 1 h by 2 pi. These are all the formulas that you have here. Okay. These are all the formulas that you have. Okay. Right. Definitely, Sai, everything is there in the Sigma batch, right? And right now, Freedom Sale is also going on in the Sigma batch. So, the batch is at a very low price, only till 17th of August because of the Independence Day, right? Freedom Sale is going on, so that's why you can get benefited out of it, right? Okay. So, now let's do some questions, and from these simple topics also questions are asked, like JEE Mains 2023 question is maximum number of electrons that can be accommodated in a shell with n is equals to 4r. In a shell with n is equals to 4. Okay, so maximum number of electrons in a shell that can be accommodated in a shell with n is equals to 4. So, you know, there are two ways of answering this. Okay, I'll answer you with these two ways only, right? So, first way is doing the full-fledged answer. Like you will say n is equals to 4. If n is 4, then L can have how many values? It can be 0 to n minus 1, that is 4 minus 1, that is 3. 0, 1, 2, 3. Okay. Now, if L is equals to 1, 2, 3, that means it will be S, P, D, F, isn't it? It will be equals to S, P, D, F. Now, if it is equals to S, P, D, F, then can I say that this S here, this is actually, if I mark different values for this one, this is L is equals to 0, this is L is equals to 1, this is L is equals to 2, right? L is equals to 0, 1, 2, 3. Okay. Now here, if L is equals to 0, that means ML will be equals to 0. Here ML will be equals to minus 1, 0, plus 1. Here it will be equals to minus 2, minus 1, 0, plus 1, plus 2. That is D. And here it will be equals to what? This is plus 1 and this is plus 2. And here ML will be equals to minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3. So either you can answer it this way, that this value is giving you 1 orbital, this is giving you 3 orbital, this is giving you 5 orbital, 1, 2, 3, 4, 5. This is giving you 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 7 orbitals. This will have 2 electron, 6 electron, this will have 10 electron, this will have 14 electron. You can add it, 24 plus 6 is 30, 32. Okay. When you add it, 2 plus 6 plus 10 plus 14 is equals to 32 electrons. Either you can answer it this way, or you can just simply say, just by one formula, maximum number of electrons that can be accommodated in a shell n is equals to 4. If shell is n is equals to 4, if I say shell is n is equals to 4, number of electrons in a shell, formula is 2n square, it is 2n is 4 square, 16 into 2 is nothing but 32, and here you have your answer. Okay. So you have two ways of answering this. Either you can answer it directly, right? Either you can answer it like directly, like with the help of formula, Or you can answer it this way. This you should know for the knowledge purpose. You should know that how we have these formulas, right? But application of formula is important in the exam. In the exam, you will answer only with the application of formulas. Okay, right? Now, let's do this thing, that is number of orbitals associated with quantum number n is equals to 5, ms is equals to plus half. Orbitals in a formula is simple. Number of orbitals in a shell. In a shell, how many orbitals you will have? This is given to be shell. Principal quantum number is given to you. So how many orbitals you will have? That is n square. That is nothing but 5 square. That is nothing but 25. Okay. So 25 is going, but you say, ma'am, they have asked, ma'am, ms is plus half. If in one orbital, you will have only one electron that is plus half, na? You will have only one electron that is plus half. You won't have two electrons that is plus half. In one orbital, there are two electrons. One is plus half, other is minus half. If they are asking you the orbitals associated with quantum numbers where ms is plus half, that means they are asking you the orbitals only, right? So answer will be 25. So answer will be 2 is the correct answer. That is your JEE 2020 question. Okay. Guys, tell me if that is clear. If till here you have any problem, then you can let me know. Right? Because quantum numbers is all about this chart. If you remember this chart, you can easily answer the questions here. Right? If you everything that you need is on this chart. Take a screenshot of this chart. This is very important. Okay? Everything that you need is over here. Right? Okay, yes. Yes, everybody. Now, let me introduce next topic, that is very important. Now we are moving deep diving towards it. Okay, so let's understand what is r, what is theta, what is phi. Okay, so this wave function, that the solution of which gave us the quantum numbers, it actually has three variables in it. One is r, other is theta, other is phi. Okay, so this r is nothing but it is called the radial wave function. It is called as radial wave function, right? That means in a circle from the nucleus to that, how much radius you have, that is the radial wave function. Then you have theta and phi. All this is in detail in masters and BSc, right? In your syllabus, it's not that much in detail. You just need to know what are these things, right? So this is called angular wave function. Angular wave function. Angular wave function is nothing but that is defined by theta and phi. So what you will see here, this is x, this is y, and this is z axis, this is z axis, this is x, and this is y, right? Radius means, let's say this is the nucleus, okay? So how much is the radius? That is defined the radial wave function. Now, from this distance, if you have this angle, that is the angular wave function. Angular, what angle you are measuring? This distance, this particular line, its angle with z-axis is theta, that is theta, and its angle, the shadow of this, when you draw a shadow of this line, corresponding to this line, you have this particular shadow, you cast a shadow. That shadow, it is making what angle with the x-axis, that is called phi. That's it. This is all you need to know, right, about theta and phi. They are angular wave function. Two ways we study this. One is radial, on radius. One is on the basis of angles, right? One is like how much you are walking, what is the distance. One is your angle. Are you moving to this angle? For example, you're going from your home to your tuition, right? So when you're going, what is the distance? That is radial. What is the angle? Are you moving to this direction or this direction or this direction? That is the angular wave function. Okay, right? Okay, everybody. Based on this, you have nodes. Okay, so what are these nodes? These nodes are simple things. These nodes are nothing but these are the point where you can't find any electron, right? I'll show you one example of that. I have taken some screenshots for you guys, right? For example, can you see this thing here? Can you see this thing? This we will derive that how this is formed. We will derive that, right? If you see, this was the nucleus, this center was the nucleus. Then you have some electrons here. With pink, we have drawn the electrons. Pink is telling you the probability of finding the electrons. You have electrons, and with this and this area, this and this area, if you see this, even if you don't mark it, can you see this without marking it, that this particular area is actually black? There is so many electrons, then one circle where the electrons are not there. Then again you have the electrons. Now this area where you can't see any electrons, that is called nodes. Okay? And when you draw the graphs and diagrams, we are going to discuss about radial nodes, right? Angular nodes, we are not going to discuss. Only the formula is in our slate. Only formula. We are not going to discuss the angular nodes over here, right? All these are the diagrams that we will discuss. And from these rules now, we will discuss about the graphs also, right? Now let's understand the nodes, okay? The region where probability density function. Now what is this probability density function? Don't worry, for you right now, it is the probability of finding the electron, right? That means they are saying psi square. Reduces to 0. Firstly it is there, then it is 0, then again it is starting, right? So it is called nodal surfaces. And if you see, there are two types of nodes, just like you have two types of function. Radial wave function will give you radial nodes. Angular wave function will give you angular nodes. Okay, my throat is again blocking. Okay. If you see, radial nodes are going to give you, are given by radial wave function. It is in the spherical, in the radius line. Okay, because I showed you radial wave function, right? It represents a sphere at some distance from the nucleus where probability of finding the electron is 0. And here we are talking about angle. It represents a plane passing through an orbital where probability of finding the electron is 0. Right? A plane where it is 0. A full plane where finding the probability of the electron is 0. And I'll also show you how you find that plane. Okay? I'll just show you that. This is radial node. In a circle from the nucleus, when you see the distance, that at this particular distance, the probability of finding the electron is 0. That is the radial node. But if you see the angular node, okay, if you see the angular node, this all will discuss. This is the angular node. This is a plane. This is a plane. If you pass this plane, right, then along this plane, the probability of finding the electron is 0. Okay? If you see along this plane, the probability of finding the electron is 0. Along this plane, the probability of finding the electron is 0. If you see this here, it is here, this is the radial node, this is the radial node, and this is the angular node. Can you see a beautiful thing, guys? Can you see that? From the here, it is altogether a plane, right? Plane means if I pass a plane from this side, then that plane will not have any electrons, right? That is the probability of, that is angular node. But if you see here, you have electrons, then you have some gap, then again you have electrons. Now this is from the nucleus. This is not a plane. This is not any plane that I am passing a plane here, right? This is a proper from the radius. I am saying that, okay, this is on the radius side that the probability of finding the electron is 0. That is called radial node. Okay. Yes, everybody got it. This is the best example to see angular and radial node. If you see this here, which is, see, I can see 2-3 gaps here. I can see gap is over here. I can see gap is over here. I can see gap is over here. These are the gaps that I can see, right? But if you see this here, you pass a plane through this particular part, and we know that you go beyond this, you will not find any electron. That is the plane. But if you see this thing, this is the nucleus. At this distance, you have electron. Then at this distance, you don't have the electron. At this distance, you have the electron. Then at this distance, you don't have the electron. That is your angular node. Okay. Beta, angular node, na, just give me a second. If you want to see this more detail, wait a minute. Yes, beta, you can see, but just be careful, right? Because this topic is slightly tough. Okay. So, dekho. Why angular node is called angular node? You love cone? Do you like cones? I love cones. Right? Ice cream cones. This is actually angular node. This is how it looks like. Right? Now, when you pass this, like radial node is through the radius. Angular node is basically the angle, like through some angle we are talking about. And in a simpler way, right, because we can't see it in 3D. So in a simpler way, we say that, how do I explain it in 2D? Wait a minute. Let me just see if I can use any prop. Wait a minute. Let me just see if I can use any prop. So guys, see, this is, imagine that this is p orbital. Okay. This is how p orbital looked like. Na? This is how p orbital was. I'll tell you about p orbital. I think I need one more class for this. Right? Because to teach you this in detail, my throat is also not working now. This is, let's say, p orbital. Right? Now, this particular part here, right, that is having no electron. This red part is the electrons. Here you have electron, here you have electron, right? If you pass a plane through it, right, if I pass my hand through it, if I pass a plane through it, that my hand does not have any electrons, right? That means this is angular node, right? Okay. But when you see a sphere, right? But when you see a sphere, that I don't have any wall as such here, right? But if you see a sphere here, in this particular part, there is nothing like that. There is no plane that I can pass. I am not passing a plane here. I am not passing a plane here. I am not passing a plane here. This is distance. This, at this particular distance, I can see the electrons are less. I can see that here electrons are very high density of electrons, then finding the electron is 0, then it is again going maximum, then again it is decreasing. Okay, ठीक है? Okay beta, tell me if that is clear or not. Please tell me in the chat box. Right, this, if you see, this is the best diagram to understand this, that this particular portion, I'll tell you, see, basically what we learn is, we learn this thing, that this is p orbital. In reality, this is what is happening in p orbital. This is the diagram of 3p orbital. Okay, this is the diagram of 3p. Acha, I'll tell you also with the help of formulas. Okay, now if you see the formulas, formulas are for radial node, it is n minus l minus 1, n minus l minus 1. For angular node it is l, for total node it is n minus 1. I'll apply the formulas now. Okay, let's see that. Let's see if you can find that or not. Let's apply the formulas. This is 1s. Okay, this is 1s. See, for 1s, how many radial nodes you will have? How many radial nodes you will have? You will have the n is equals to 1 and l is equals to 0. So it will be 0. Angular node is also 0. Can you see any node here? No. You will say, ma'am, here, ma'am, node is there. Array, that is infinity. Node is when after that gap, again it is increasing. Is it increasing after that? Can you see more density of electron here? No. If it is only decreasing, there is no increment after it, then that will not be node. So can you see any node here? No. Right? So if you see this here now, what is this? This is 2s. N is 2, L is equals to S, P, L is equals to 0. Right? Now, L is equals to 0 here. Right? Now, if I say L is equals to 0, then in this way, can I just simply write it here? Radial node will be equals to N minus L minus 1. Angular node will be equals to L. Can you see any angular node here? Is there any plane that I can pass which has 0 electron density? Can you pass this plane? No. Can you pass this plane? No. Can you pass this plane? No. It has density. So that means definitely plane is 0. That's why angular node is going to be 0. But I can see here it is going towards maximum, and this is your radial node. Where it is decreasing, then again it is increasing. Okay. Okay. So now let's see this. This is how it actually looks like, that I'll tell you in the next class. Right? Now 3s. N is equals to 3. L is equals to 0. For S, L is always equals to 0. Right? So radial node will be equals to N minus L minus 1, that is 2. Can you see 2 radial nodes here? Can you see that? I don't know if you're able to see that or not. Very carefully you have to observe that. It is over here. It is over here. Right? Then it is over here. Okay? These are the 2 radial nodes. It is not clearly visible here. It should be like this. Okay? It is not that clearly visible here. It should be like this. Chalo, it's not that clearly visible, and I can't also make it like that. Right? But it's over here and it's over here. Right? These are the 2 radial nodes. And what about angular nodes? It is equals to L, that is 0. So S orbital will never have any angular node. because S orbital is always spherical, right? That's why it will never have a spherical, have an angular node. Beta, tell me if you can understand this or not. Please tell. Okay, don't be so uh, like totally lost in the charts that you don't know what the teacher is saying. In 2p, this is 2p. Again, the angular node and radial node. Radial node is n is 2, L is 1, so it is 0. Can you see any radial node? No, ma'am. What is this, ma'am? What is this? This is angular node. This thing is angular node. It's a plane. Angular node here is equals to L, that is equals to 1. This is the angular node that you have. Okay? Right? Yes, beta, they teach from chapter 1. Right? Okay? ठीक है जी, they नहीं, we only. We teach there. Right? So, this is the plane. Beta, tell me if that is clear. ठीक है? अच्छा, plane, we have a better diagram for plane. Plane is not that better. Okay, I think I'll draw it myself. This is the plane that you can pass from here. Okay. Now, similarly, 2px, 2py, 2pz, it is the same that we will discuss in the next class. This is 3p. Okay. 3p is also n is equals to 3, L is equals to 2. So, radial node is equals to 0. That's why on radius you can't see any radial node. Wait a minute, n minus, wait, it will not be 0. There is one radial node over here, right? So 3 minus 1 minus 1, that is 1. Okay. Angular node is also 1. Can you see that here? Can you see that the angular node, the radial nodes? Yes. Which is the angular node, which is the radial node? If you see this here, this is where you can pass the plate. This is where you can pass the plate. This is where you can pass the plate. But these are angular nodes. Angular nodes. These are the planes. And this part is radial. This part is radial. This part is radial. Right? Okay. Yes, everybody. Then this is for D, right? For D, it's slightly more complicated, right? So what I'll show you, just simply do this thing. For 3D, just simply do this thing that it is 3, radial node is N is 3, L is 2, minus 1, that is 0. Angular node is equals to 2. So here you will see two angular nodes, two planes. This is a better picture to show that. This is the first plane that you can pass. This is the second plane that you can pass. One will cut like this, other will cut like this. These are the two angular nodes in D that you will have, and D will not have any radial. Okay. Yes, students, tell me if that is clear to everybody or not. Okay. So I've also shown you with the help of diagrams. If you see this here as well, this is a better diagram to understand that this is a plane. Okay. This is also another plane. So that's how it has two angular nodes. Okay. That's how it has two angular nodes. Here also, this is the plane. This is the plane that it can pass. So two angular nodes. Here also, this is basically dz square. We'll learn about it. This is exactly one plane that you can pass from here and another plane that you can pass from here. That is your angular roots, right? Wait a minute. Huh. dz square is different. That I'll show you in the next class. Okay? dz square is different. All of them in 3D, there is an exception here that I'll tell you in the next class. This is the exception. And let me see how many of you are able to find it out. How many nodal planes you have here? Because this is a very important question, especially for your JEE mains. Because these kind of theoretical questions they can ask you that in dx, y, yz, dzx. I'll tell you all of that. It has two nodal planes, two angular nodes it has. But dz square is different. Okay? Right? Chal. So guys, that's it. Now my throat is also not working. And I'll see you all in the next class, that is on Saturday, where we are going to discuss about radial graphs. We are going to discuss electronic configuration, radial graphs, how to draw those graphs, and we'll discuss more questions on quantum theory. Okay? Okay? Chal. Okay then everybody, now I'll see you all in the next class, and do let me know in the comment section. This is your homework. This is the homework. dz square has how many nodal planes? dz square has how many nodal planes? It's an exception, okay? dz square has how many nodal planes? Okay? Yes. Okay then guys, now I'll take your leave, and before going, a very important information for all of you that you were discussing in the chat box. See, when the time is right, I'll discuss everything, right? So now the time is right. Now I'll just show you this over here, right? This is a Sigma Express batch, right? And right now our Freedom sale is going on, where this batch is available. Can you see at just 1499, right? So at just 1499, this batch that is of 7999, it is available, right? So nothing we are, it's not like we'll not give you something that we have given to the students that have bought it in a more price. It's just that right now for 5 days sale is going on. That is your Independence Day sale, right? After 17th of August, this price is not going to come back, not come, right? So if you're thinking about joining the batch, then this is the batch for you. Click on the enroll now option right over here, and you will get to the pool, right? So this batch has 79% off, right? Sigma Express batch, that is at 70% off, right? Okay. So guys, that's it for today. Now I'll see you all in on Saturday's class, where we are going to complete this particular chapter, right? So till then, bye bye, take care, and see you all in the next class. Bye bye.